What I link? What is it? Indian meeting about AMC. ও এটা সলভ করতে দিয়েছে নাকি? মানে অঙ্ক ক্লাস হলে সেরকম কিছু ইনফরমেশন দিল। ওকে ছেড়ে দেবো। হ্যাঁ এখন
Abhiraj, your answer is not correct. Try again. Pratik, answer is not correct. Tanay, not correct. Harsh, correct. Okay, कुछ लोग का आंसर आ रहा है. Akshita, not correct. Aditya, correct. Abhiraj, not correct. Ayushman, not correct. Ishan, correct. Okay. I'll discuss the solution for this question. So see that we can assume this side is x, and since this is a right angle triangle with angles 60, 30, and 90, this is one of those standard triangles in which you will have uh, the smallest side is half of the larger side, because you can see that this is actually one half of an equilateral triangle, 60, 60, 60. And if you put a median, altitude, angle bisector, whatever, uh, uh, this remaining this remaining triangle that we get, which is a part, which is half, exactly half of our equilateral triangle, has the property that the longest side is 2x if the shorter side is x. Okay, no need of using trigonometry in case someone knows it. This is a standard result from standard triangles. So if this is x, then we have EC as 2x. Alright. And from Pythagoras theorem, I can say that root 3x. Okay. Next, I'll show that this triangle, this triangle, and this triangle are all congruent. I hope everyone remembers and knows what congruency is and how to prove it. See that FE is equal to ED because DEF is a equilateral triangle, right? And since this angle is 60, 30, AEF is 90. Angle AEF is equal to angle AEF is equal to angle CDE, which is equal to 90 degrees. And also we have angle C is equal to angle A. So from this we can easily say that these two triangles uh, are congruent because we have angle, angle and one side. So SAA congruency, we have triangle AEF congruent to triangle CDE. And this is not limited to these two triangles. So I can write similarly. This congruency extends to the third triangle also. Congruency will extend to triangle AEF and uh, BFD. Okay. Since all of these are congruent, this will be x, this will be 2x, this will be x, 2x, root 3x, and root 3x. All the sides are now known in terms of our smallest side x, which we had assumed. Okay. So now we can directly compare the areas. Area of ABC is equal to root 3 by 4 a square, and that is equal to root 3 times 3x the whole square by 4. I'll just leave it like this. And then area of DEF. Now the side length of DEF is again root 3 by 4 b square. The side length of the triangle of this DEF triangle is b. I'll assume that. And then I can say root 3 by 4 root 3x the whole square. I actually don't need to calculate the areas anyways because you can notice over here that the difference between these two triangles is that the sides have been scaled by root 3. This was 3x and now the smaller one is root 3x. So there is a ratio of root 3. So I can directly say that the area is square is proportional to square of the ratio. I hope everyone understands. In case you have studied similarity, this would be perfectly clear to you. But now think of this. You have a plot of land. You make it double size through length on both sides. Length and breadth both you double. Then it is obvious now that area becomes 4 times. If you had doubled, if you instead of doubling, if you had done 5 times, the area would have become 25 times, and so on. Similarly, with volume, it becomes cube. So with the area, it becomes square proportionality. So we have area of AB, not ABC, DEF by area of ABC is equal to 1 by 3. And that was what was asked in the question. Area of DEF to the triangle ABC. So answer will be 1 by 3. Similarity, knowledge of similarity is not required. You can simply use the area formula. This just I'm saying, I'm giving extra ways to think about the question. Okay. So answer is 1 by 3. Try this question. Try to think of what is the pattern between each row. It is this kind of structure is linked to a very important uh, mathematical object. You all know about it. Try to see what the pattern is over here. It is not as straightforward as the other thing.
हम्म मैं मेरी क्लास है, नहीं समझा करो यार, ऐसे क्या करते हो? वही कर रहा हूँ मैं।
Siddharth, correct answer. Abhiraj, answer is not correct. Try again. Akshita, try again. Diya, try again. Rakesh, try again. Everyone is giving all. So I have gotten five answers so far. All the answers are different. Abhiraj, try again. Reyansh, correct. Okay, I'll give 2 minutes. After that, I'll start solving it. They are not correct. Shivan not correct. They are again not correct. Okay, yeah. Rushika correct. Apart from that, all are not correct.
Is it 62?
You can put the answer in the chat, but yeah, no, it's not correct. 62 is not correct. Riyansh, your answer is correct. Okay, I'll solve the question now. The triangular array of numbers 1, 2, 3, and so on. So you notice that our regular Pascal's triangle goes like 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. Correct. Over here, we know the obvious property that each row sums to two's power, some power of 2, basically. This is 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 4, and so on. You can see this. No, 2 to the power 3. Sorry. Why is this happening? It's happening because Pascal's triangle has the property that every number, like if you look at 3, it is the sum of whatever number was above it. Correct? That same property you can see over here. 4 is the sum of 2 plus 2. 15 is 7 plus 8. And then 11 is 7 plus 4. And so on. The same property is being valid in this throughout this pyramid. Where it is not being valid are these edge cases. 5, 4, 3, 2, 1. You can see they are coming. So 5 is getting 4, but it is 1 more than 4. So there is some phantom extra number coming into the edges. Apart from that, everything in the inner skin, everything apart from the skin of this pyramid is following the same Pascal's triangle law that each term is a sum of the above two terms. So we can correct this by assuming some ghost atoms. Um, I mean, I'm thinking it in terms of something existing over there. So I'll just put some ghost numbers. I'll put a 1 over here, 1, and I'll paint them blue. Okay, and so on both the sides. This way, we can now justify having having 1 over here, 2, 3, and 4. Now I can easily say that this one actually comes from 1 and 0. This 2 comes from 1 and 1. 3 comes from 1 and 2. Okay. This way we have completed our Pascal's triangle-ish some pyramid. Okay. Now we can directly use the property that each layer, so our layer 1 is 2 minus 2 because we need to remove the ghost numbers that I have kept over there. So in layer 1, I have the value 2 minus 2. In layer 2, these same 2 are multiplying. So this 1 is becoming 1 1 over here. This other one is becoming 1 1 over here. So I have 4 and then I'll remove my ghost numbers. Correct. And then my next layer, I see this one, this one, this one, and this one. All these four ones, all these four numbers are doubling. That we see over here 1 plus 2 plus 2 plus 2 plus 1. This is coming out to be 8. So I can write that our third layer is actually 8 minus 2. Same way, fourth layer is 16 minus 2. So our nth layer is actually 2 to the power n minus 2. And this is half of our problem complete. So we have figured out what f of 100 is. F here, they have said that it is the sum of the nth row, sum of the numbers in the nth row. And they have said that it starts from the first row. So usually Pascal's triangle, they say that this is the 0th row and this is the first row. Some people say that that's the first row, second row, something like that. Pascal's triangle, there is some ambiguity. But over here in this question, they have said that the topmost row is the first row. So this formula is valid and we can calculate f of 100 equal to 2 to the power 100 minus 2. Now beyond this, we'll use the concept of modulus to decrease our workload. Basically, what I'm trying to say is we want the last two digits of 2 to the power 100 minus 2. If we are able to find the last two digits of 2 to the power 100, aren't we done? Because we don't need to always check 2 to the power 100 minus 2 or 2 to the power something minus 2. We'll just keep checking 2 to the power 100, and once we get 2 to the power 100's last two digits, we'll just subtract 2 from it and we'll have an answer. So I'll write 2 to the power 100 as 2 to the power 10 to the power 10, because law of indices allows me to do this. This will be 1024 to the power 10, and then 1024 mod 100 is equal to 24 to the power 10. Mod over here is basically remainder when divided by this number. Okay, or all those numbers that give the same remainder. Okay, so anything above the hundreds place or the hundreds place won't affect the remainder. Correct. I can add another 10,000 square, 10,000 to the power some big number, anything. Only last two digits is required. That's why I'll only consider 24, and I'll raise 24 to the power 10. Now 24 times 24 is, I'll just write it fast, 576. And then you notice that 576 is equal to 600 minus 24. And when you multiply this by 24 again, you find that 24 times 600, last two digits, there is no contribution. But what will contribute is minus 576, which is equal to minus 600 plus 24. So in essence, what I'm trying to say is that 24 24 has this neat property, 24 to the power n mod 100 has this neat property that when 24 to the power 1, we get 24. When we raise 24 to the power 2, we get 576, which is equal to 76, which is equal to minus 24 mod 100. Again, I'm talking about mod 100 only. When we do 24 to the power 3 or minus 24 times 24, I get minus 76 and a minus sign outside, which is 24. And then again, when I multiply 24 by 24 again, I get 76 and then 24, 76, 24. This pattern keeps repeating. So 24 to the power any number, uh, when divided by 100 or the last two digits if you are checking, it will be either 24 or 76. So we can just go and check, is this number that we are raising 24 to, is it an even number or odd number? Since it is an even number, mod 100 will be equal to 76. And answer will be 2 to the power 100 minus 2 mod 100, which is equal to 76 minus 2 mod 100, which is equal to 74. Now, in case anyone is confused, just think again of what mod is doing. Is it what mod is doing is basically it's dividing the previous number by 100. Whatever remainder we get, any other number that gives the same remainder when divided by 100 will satisfy such an equation. This is what the theory of modulus is. Think of a clock. If someone asks you what is 7 hours after 10 p.m., you can calculate fast in your head. Now it's 5 a.m. That same concept. After 10 or after 100, whatever number comes, we are only caring about the last two digits. Okay. So this way we get answer 74. And over here is option. Whoever got 74, very good. Okay. Try out this next question. So there are 7 students and they need to be split into 3 groups or less. It can be 2 groups, it can be 1 group, anything. Uh, Achita, what is your doubt? I don't understand. To sew. I mean, it's the you can. So the thing is, there are three groups. I'll make the question more concise. There are three groups in which you want to put these seven people. Okay, these three groups are made. A group can remain empty also. Okay, that is what the question is. So again, I'm repeating. There are three independent groups in which we are putting seven students inside. Think about what all can happen. I see a few answers over here. Okay, no one's answer is correct. Don't overcomplicate the question. There are three different teams. So sort of think of this as three houses in which seven students need to be distributed into. How many ways that can be done? It's a straightforward answer. Okay, fine. No one is getting close to the answer. Uh, See, there are seven students. For each student, I can ask, which group do you want to go into? Correct. So for each student, there are there are uh, three options, and there are seven students. See, there are too many people have answered, so it's all uh, it's like a waterfall. I don't seem to find any. Some student has done some opposite method. So seven to the power four also people can give an answer. Okay, each student have option of going into either one of these groups. So the answer is 3 to the power 7 because there are three choices per student and there are seven students. So I'll just multiply all the choices. It will give me all the ways of distributing them into three groups. Fine. Has everyone understood what I was trying to say?
Can you just
The
explain
power
it
7.
again?
Is it? Huh? What happened?
Yeah, can you just explain it again?
Acha. So there are three groups. Think of this as the houses in your school. So there will be some red house, blue house, yellow house, green house, or some other colors also. So now just think there are only three houses into which seven students have to be now placed. So I'll go ask the first student, which house do you want to go into? He will say, okay, I want to go into the red house. Okay. Then second student will say, I want to go blue, and so on. So you see, there are these many choices. There are per student there are three choices, and each student has an independent choice to make. So all the choices I'll simply multiply. Correct. 2187 or 3 to the power 7 is correct. Okay. I hope everyone understood. Okay. Now try out this question. Question number 4. It's along the same lines. You need to think along the same line, is what I'm saying.
So can one of the numbers be 1?
Yeah, that is also allowed. Three element positive set. Na. Again, think the question 3 and question 4 has the same exact logic. You just need to try to um, convince yourself that that is the case.
Sir, and they're all distinct as well, right?
No, that is not necessary. That's what I'm saying. Now, the question 3 and question 4 situation is exactly same. I mean, these options, what I want to ask you is ordered on unordered sets. Or ordered sets. So forget about these options. I modified the question. Otherwise, the question becomes slightly complicated.
So is my answer correct?
I want ordered sets. Unordered sets, you'll get a different answer. Whatever answer you're giving is probably correct. Again, your answer is correct. So basically, what was supposed to be done over here was 2310 is equal to 2 times 5 times 231, where 231 is 21 times 11, and 21 can be written as 3 times 7. So we have 2 times 5 times 3 times 7 times 11. So we have five prime numbers, and now if the situation is same, we are asking these five prime numbers, which sets do you want to go into, either A, B, or C. So in that case, it will become 3 to the power 5. But the options are unordered. See, the level of the question is different. That's why I'm not uh, asked you to find the ordered sets. Okay, that becomes slightly more complicated. But for, I mean, I'm not asking you to find unordered sets. Ordered sets, it's a straightforward answer. All right. Try out this question.
Sorry. So can you please call up for a second? Okay, sir. Got it.
So in the previous question, 1 can also be a number.
Yeah, one can also be a number, and then both B and C could be one, both A and B could be one, and that's what. Here they have not mentioned whether it is unordered or ordered, and the options are small, so you have to assume unordered sets. But so the difference between ordered and unordered is 2 comma 1 and 1 comma 2 are different sets if we are talking about unordered sets. I mean, they are different sets if we are talking about ordered sets. Okay, the ordering is different. 1, 2, and 2, 1, the ordering is different. That's why
So
if
is
I say
all of
ordered,
B,
yeah, what
right?
happened? Unordered sets, we can discuss it towards the end of the class. For now, you can try out this fifth question.
Sir, I sent my answer.
Just a second. So, Reyansh, your answer is correct.
Is my answer correct?
Avigyana, not correct.
Is my answer correct?
So, E is not the center. In case everyone is saying 180 degrees or 108 degrees, E is not, like the point E is not the center.
Oh, is my answer correct?
Uh, who is asking?
Abhiraj?
Abhiraj, yeah, not correct.
Is my answer correct?
So far only one has got the answer correct. Reyansh.
Is my answer correct?
Yeah, only Reyansh has got the answer correct. No one else so far.
Sir, can you check my answer?
Yeah, it's not correct. Not correct. Try again. Think about it. It take 5-10 minutes for this question.
You can check my answer.
Harsh, correct answer.
Sir, check my answer.
So, okay, so okay, too many answers.
Is 120
Abhiraj
the answer?
correct. Akshita correct. Okay. Yeah.
Is
So
my answer
you
correct
guys are
now?
getting the answer. Yeah. 144 is the answer. I'll solve it. Just a second.
Sir, we have to construct the radii from P to A. Then it's solved.
E to A. Yeah, basically from D to A. Yeah. To the center you need to construct, and after that question is done. So I'll copy the image. Okay. Here what is happening is we know that for a pentagon angle, since it's a regular pentagon, it has been given 108 degrees is the angle E. Angle E equal to 108 equal to angle A equal to angle D and so on. All of these angles are 108 degrees because 540 degrees is the angle sum property of pentagon. Now what I'll do, I'll take perpendiculars from A and D. I mean line segments perpendicular to DC and AB originating from D and A respectively. Now these two line segments must intersect at the center because tangent or the line perpendicular to the tangent at the point of tangency passes through the center. Correct. So this is our O center. Okay. I'll extend these two lines now such that they'll meet at some point over here N. Okay. This angle is 108, 108. So this will be 72, 72, 72, 72, so 36. Now we have a quadrilateral ADNA, AODN, sorry. AODN is a quadrilateral which has two angles 90 degrees, 90 degrees. Correct. These two angles. So if this is 36, then the remaining angle O will be angle O is equal to 180 minus 36, which is equal to 144. Got it?
Sir, alternatively, sir, ODCBA is a pentagon, so its angle sum is 540 degrees.
That also you could do. You can directly say that, yeah, that can also be done. So this angle is 108. This angle will be how much? 18 and 18. So you can add 18 and 18 to 108 to form this remaining angle. You're able to see now. That also can be done. So angle O is equal to 108 plus 18 plus 18. That will also give 144. Because you're pulling this outside sort of. You're taking a point at E and then pulling it outside. So you will add the two angles. It's like a double
How did you
exterior
get?
angle property applied all together.
How did you get
Or
18
you can
degrees?
use yeah. Yeah, what happened again?
How did you get 18 degrees?
108 minus 90. So since all the angles are 108, na,
Oh, right.
I
Okay.
remove 19. So this is 18, 18. That
Yeah.
whatever way, this is an objective paper, na, whichever way you find fastest, that is your personal method to solve it. Okay. So this answer is 144. Try out this question.
That's my answer.
Yeah, just a second, I'll confirm. Uh, Prakeet, right? Try again. Akshita, correct answer. Reyansh, try again. Dakshal, Anshu, Abhiraj, not correct. Dheeraj, I don't understand what your option is. Just mention the option number. No? Okay. Dakshal, correct answer. Diya, Aditya, Dheeraj, Rushika, not correct. Abhiraj, not correct. Anshu, not correct. Okay, first of all, I'll not show you how to solve this question through the correct method. I'll show you how to go about doing this question in the fastest possible manner. Not doing any assumptions and I mean, not doing any equation making and writing and all that. Fine. Uh, what I'll do is I'll do some trial and error. Let m equal to, not m equal to, let h equal to 0. Since this is a like thought experiment, na, we can take any value we want. I'll explain the situation also. Sunny and Moonbeam both run at the same pace. It just turns out that Moonbeam runs faster than Sunny by a factor of m. Okay, and then what they want is there is a race that is going on. Sunny starts here, Moonbeam starts here. They want to reach this end point, which is uh, this is the total distance d that Moonbeam is going to run at which point he will overtake Sunny. Correct. and this is the head start h that they're giving. Now, can you agree that let h equal to 0 is a nonsense situation, but still mathematics will give a result for that situation also. Our final answer, or whichever equation, whichever of these equation is the correct answer, must give the correct response for this situation also. Correct. So just check when we put h equal to 0, what does logic say? If we give no head start, instantly moonbeam will overtake because moonbeam is obviously faster than sunny, right? So we'll eliminate options. Putting h equal to 0 does not make this option 0. So I'll remove option E. Okay. So this implies that E is not an option. Okay. Then I'll say let m equal to 1. M equal to 1 is also a nonsense case where moonbeam and sunny speed is the just exactly same thing. But our equation, when m tends to 1 and there is a finite h, we must get infinite value. Now, think about it. If you and your friend have the same speed and that friend of yours is getting a head start of some finite distance, you will never be able to catch up with that guy. Correct? The answer should be infinity. So there should be some sort of zero in the denominator kind of situation. So this way you can eliminate this equation. Hm goes away and this also goes away. H upon h plus m also goes away. Because these two are giving finite answers for a situation in which the answer should have been infinite. So we are only left with these two options where we need to check. Now we can put m equal to 2. If m is 2, then whatever distance sunny covers, this let's call this distance covered by sunny, moonbeam will cover the double the distance. So this is distance covered by moonbeam. Correct? So whatever distance sunny covers, distance covered by moonbeam will be double. So we can just see if this is the head start, then the distance covered by moonbeam will be like obviously 2h. So whichever of these equation gives the answer 2h is the correct answer, and that is D. So this is how you do option elimination for such a question and get the answer very fast. Otherwise, you can do it in the correct manner in which you should do a subjective paper. So we'll assume the speed of sunny is equal to s. Speed of moonbeam is equal to ms. Correct. So let this distance d, distance covered by moonbeam, is equal to d, I'll assume, and the distance covered by sunny is some uh, distance. I'll write this below. Distance covered by moonbeam, if we assume that this value is d, then distance covered by sunny will be proportional to its speed. So it will be d by m. Whatever distance moonbeam covers, distance covered by sunny will be 1/m of it in the same time. Okay. So from this we have that I'll copy this. Okay. We have found out that this is d by m. So d minus d by m is equal to h. And from here we can say that d 1 minus 1 by m is equal to h and d is equal to mh m minus 1. So both by correct means and also through option elimination, we can get the same answer. Fine. Uh, does anyone have a doubt? Whatever I did over here. Anyone wants to discuss? Okay, try this question. Some people are saying no. Do you have no doubts or you want me to not proceed? I guess it is no doubts now. It's just substitution. There is nothing more to this question. Get the answer fast. Shiven correct. Avigya, Avigna not correct. Anshu correct and Ishan. No, Anshu not correct. Ishan correct. Dakshal correct. Rayansh not correct. Aditya not correct. Akshita correct. Sumit not correct.
Sir, option C.
Pratik not correct. Diya not correct. Option C is not correct. Dheeraj, I'll explain. Avigna correct. Rushika, Akshita correct. Anshu correct. Abhiraj not correct. Okay, fine. I've given enough time to solve, and time is up for the class anyways. So, uh, f of x is equal to this weird stuff. What you need to notice that when we put 0, f of 0 and f of 2 are trivially 0 because this is a product of two terms. So 0 to the power 1 times anything equal to 0, correct? And uh, 4, so x is minus 2 in the situation that x is minus 2. We have minus 2 plus 2 to the power minus 2 plus 3, which is also times anything, is 0 because it is 0 to the power 1, which is of the form 0 to the power 1, correct? So f of 0 and f of 2 equal to 0, and the reasoning I've given over here. All we have to do is calculate f of minus 1 and f of minus 3. F of minus 1 is minus 1 to the power 0, which is 1. It's not 0. You can't eliminate it over here. Multiplied by my minus 1 plus 2 is 1 to the power anything is 1. So to the power 2 over here, which is equal to 1. So f of minus 1 is 1. And then f of minus 3 is equal to, you put minus 3 to the power 2, minus 3 to the power minus 2, sorry, times 1 to the power 0. So 1 to the power 0 is again 1. It's not 0. Okay. So you get 1 upon minus 3 the whole square, which is equal to 1 upon 9. So you have to simply add 1 plus 1 by 9. This is equal to 10 upon 9. So I see you guys have done the error that either you have taken minus 1 instead of 1 or minus 1 by 9 instead of 1 by 9 and got different answers. But this is how you are supposed to do it. Fine. We'll meet next time whenever the class is rescheduled. I have no homework questions for today anyways. Most of you have probably given NMTC stage 2. If not, take NMTC stage 2 as the homework. You will find the question paper somehow. And if you have given NMTC stage 2, then rest for today. Okay. Bye guys. In this question, does anyone have a doubt? Any fundamental question or something? If not, I'll leave. Okay. Bye. Bye guys.
Bye, sir. Thank you, sir.
Bye, sir.
Bye, sir.
Bye, sir.
Bye, sir.